So composition of functions basically means we're taking one function and we're plugging it into another one where x is.
Great.
And if you have two functions, f of x and g of x, you can do them two ways. You can plug g into f, or you can plug f into g. If we look here, so notice normally your function would be f of x. That's what it would normally be. So in this one right here, we've replaced the x with the function g of x. So that means we're taking g of x, we're plugging it into f, and replacing x. And so we can write that two ways, like this, with a little strange O between them, or with the parentheses. I prefer the parentheses, but they're both the same. And the way that you would read that is f of g of x. Of x. F of g of x. And so that's how it could look right there. And of course, the reverse would be g of f of x. So we're going to go to that example on the back. I'm starting with the hardest one, and then that means Thursday's class will be easier. This is going to use a lot of the same skills that we've seen throughout this year. But we'll start here with f of g of x. So remember, this means plug g into f. So I'm basically going to replace this x right there with all of this, and this x right there with all of that. So I've got, in the original, it's x minus 2 over x minus 1. So now, instead of x, we're going to have the function g of x. And then we're going to simplify. Now, we'll go through the simplification process. So, do we see what's happening here? Do we see how the function g of x has replaced x in f? Feeling good? Okay. When we first do this, we want to check for domain restrictions real quick. We want to do it right away. Do you guys see a fraction somewhere that has x on the bottom? Yeah, I see it in two places. You guys see it in two places? Right there and right there. Okay, so we want to think about domain right now. What is a number that would make us divide by 0? 1/2. If x equals 1/2, then we would divide by 0. X is not allowed to be 1/2. So we're going to need to remember this, because actually that's going to cancel out later, which is why we have to look right now. Okay. All right, so speaking of things that we've done in pre-calc, we need to simplify this. We have a fraction within a fraction. What do we normally do when we have fractions within fractions? I thought I heard it. Fractions over fractions. Like, I remember doing tangent of double angle and seeing something like 2 times 12 over 5 over 1 minus 144 over 25, something like that. Common denominator. Yes. We're going to find a common denominator. What is our denominator going to be? 2x minus 1. So this is going to be multiplied by 2x minus 1 over itself. Remember that this is 2 over 1, and this is 1 over 1. This is going to be multiplied by 2x minus 1 over itself. When I do this, I like to not do too much at once here, especially as I'm like getting used to it. So I would do minus 2 parentheses 2x minus 1 over itself like that. So notice that minus 2 is just multiplying the top there. And then do something similar on the bottom. I find that a lot of students make mistakes when you try to do too many steps at once, like you try and combine them. And I've noticed that I make more mistakes when I try and combine steps. Once we have a common denominator on every part of this fraction, what can we do? Yeah, we can cancel it out. So that will take me to this stage right here. Notice my use of parentheses. You need those in there. I'm going to now distribute the -2 and the -1 on the top and bottom. Again, this is one of those things that as you get more comfortable, you could start doing that a little quicker. But as we're first doing it, I would really recommend break it up into smaller steps. And then we combine like terms. We need to check domain again, because now that it's simplified, we once again have a number in the denominator, x is in the denominator. Based on this here, what can x not equal? -1, +1. Subtract 1 from both sides. X cannot equal +1. That means our full domain, so x can't equal 1. Also, from the beginning, x can't equal 1/2. Notice how that kind of disappeared. So our domain would look like this. Everything except 1/2. Zoom out a little bit here so we can see all of it at once. So our full process there was plug g of x into f of x, check the domain right away. Then it was find a common denominator, cancel out the denominator, and then continue to simplify from there. So using a lot of the same skills that we've done before. At the very end, once it's fully simplified, we check domain again, and we come up with our full domain. So here would be my answer right there, as well as this. We can also do, we're going to do this next class, but we're going to do g of f of x, and we're going to have different domain restrictions, and our result is going to be different, but the process is going to be the same. Cool. That'll do it. That's the quick and dirty of domain and composition of functions.